Okay, step number 3.
Where I got the steps.
You got this? Step number 1.
To choose wisely, we need a set of generalized coordinates that uniquely specify the system.
Okay, so we have a pendulum. What do you think we should use? I'm thinking theta would be a good one. So let's use that one. So we wrote the Lagrangian as t minus v. What is t? So my unique situation is I want everything in terms of theta, because theta is something I can control. And again, this is L, and the arc is S. So my pendulum is swinging along the. Now how do I convert S to theta? Because that's what I picked. So my Lagrangian will be 1/2 ml theta dot squares plus mgl1 minus cosine theta. Oh, L will be minus. Nobody corrected that one when you're supposed to. S is L theta, right? So S dot will be L theta dot. And S double dot again is L theta double dot. Okay, what's next?
Pick which equation you want.
Euler-Lagrange equation.
First one.
What's the first one? D over dt.
Over partial theta dot minus partial over partial theta.
D over dt of ml squared theta dot minus partial over partial theta of minus mgl plus mgl cosine theta. That one goes away because there's no theta in this. So then this would be ml squared theta double dot plus mgl sine theta equals 0. So this means m again cannot be 0, L cannot be 0. So what, and for small angles, sine of theta is approximately theta. So what am I left with? L theta double dot plus G theta equals 0, or theta double dot plus G over L theta equals 0.